So now in this final category of hydrocarbons, we're going to be dealing with something called a benzene. Now in this case over here, when you take a look at the line diagram of benzene, you'll notice that there are 6 carbons here. So it's 1, 2, 3, 4, 5, 6. The purpose of this clip is to talk to you about the difference between a cyclohexane, or in this case a cyclohexane, versus a benzene. So right now I'm putting in front of you a molecule of cyclohexane. So you'll notice that there are 6 carbons. So it's 1, 2, 3, 4, 5, 6. And because each carbon invests 2 bonds to connect it with the neighboring carbons, it only has 2 bonds left to be attached to hydrogens. And so the formula of this is going to be C6 and H12. However, if you take a look at the benzene diagram over here, you'll notice that indeed we have our 6 carbons, but there are now double bonds on alternating pairs of this molecule. And so if I was to now bring this molecule to you to show you, you're going to see that we have this benzene molecule, and so in between the alternating pairs there is a double bond. And because now each of these carbons have invested 1, 2, 3 bonds to its neighboring carbons, what we end up with is only 1 remaining bond left for hydrogen. So in this case, the formula has changed from a C6 and with only 6 hydrogens. And so if we were to take a look at the cyclohexane over here, we would have a C6H12, and then for a benzene over here, we would have a C6H6. And so here we have the primary difference of the 2 molecules in the sense that we have these alternating double bonds. So in terms of drawing it, one of the things that, again, we understand is that if there's no other sort of alkyl groups or alkyl halide groups, then it is understood that there are going to be H's at these terminal ends of the carbon. And so more often than not, this molecule is drawn or represented without the H's. And so in this case over here, we would have something that looks like this. And so over here, this would be our benzene ring, now without the H's, just to clean up the structure a little bit. Now, when we take a look at the molecule over here, these double bonds are actually not fixed in space. So if you notice that right now that there is this alternating double bond in this top right-hand corner, bottom right-hand corner, and the left, this molecule can just twist, and then what you end up with is that this double bond now is on the top left hand, this double bond is the bottom left hand, and this one is on the right hand. And so in this case over here, according to Lewis dot structure representation, these double bonds are always going to be on alternating carbons, but they're not sort of like fixed in space as to where they are in this carbon ring. So how do we go about representing it? So in this case over here, when we draw this, what we end up with is we have our C6H6. So it's going to be a carbon, 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 and we finish it up here, and then we draw the double bond right here, here, and here. And again, we can opt to draw the H's here on each of the carbons. But in order to simplify this, what we can do is we just draw the line diagram. And so if we were to take a look at the line diagram over here, we would have something that looks like this. So I'm going to draw the 6 carbon ring right over here, and then I'm going to draw the alternating double bonds, or I can draw it in this way. And now my alternating double bonds is going to look this way. And so the final thing that you could actually potentially see for a benzene ring is that because we can't sort of nail down where the double bond is, what sometimes people do is they draw it and it looks something like this. So instead of a double bond on alternating pairs of carbons, what they do instead is they just draw a circle. So all three of these are potential representations using the line diagram of the benzene ring. And when we talk about the atomic theory, you'll actually begin to understand why we actually draw a circle. So when you see these representations, you should now be able to recognize that they are for a benzene molecule.